All right, so here we go. We have the formula for the equivalent resistance, which has to do with electrical circuits. The reason I picked this particular formula is I didn't think it was something you would have seen before. And so it's really a question of, can you manipulate formulas that you've never seen before? On this one, I kind of recommend starting with plugging in the values, which is kind of different than how we've done the other ones. But trying to solve for b by itself, if you try it, you'll find that it gets really messy really quick, which is okay. But if you plug in the values, it doesn't even really, at that point, it's just numbers like we've been doing. So in this case, the equivalent resistance is 3, so then we end up with 1 over 3 equals 1 over A, which is 4, plus 1 over B. Okay, so now what we got to do is just get B by itself. So what's keeping the B from being by itself? Well, it's in the denominator and the 1/4. Let's get rid of the 1/4 first. So subtract 1/4 to both sides. All right. 1/3 minus 1/4. If you go back, you got to remember how to subtract fractions. We got to get our common denominator. In this case, 3 times 4 is 12. So that's going to be 12. What do we have to multiply 3 by to get 12? Well, you have to multiply 4. If you multiply it to the bottom, you got to multiply it to the top. So we get 4/12. What do you have to multiply 4 by to get 12? You got to multiply it by 3. And if you multiply it to the bottom, you got to multiply it to the top. So you get 3/12. 4/12 minus 3/12 is 1/12, giving us 1 over B equals 1 over 12. From there, I'll let you conclude what B is all by yourself. I think you should be able to do it. If you're still confused, email me back and say if you've got any questions.